try to look at the whole universe itself, many people ask the question, well, Professor, how do you know? How do you know that the universe is expanding? How do you know that it came from a Big Bang? How can you project so far into the future, billions to trillions of years into the future? Well, one way we do this is by looking at the Doppler shift. Now, the Doppler shift is something that even children are familiar with. When children play Star Wars with each other, they go with their rocket ships, right? Well, what makes that sound? It's the Doppler effect. When a car moves toward you, the pitch is higher. When the car moves away from you, the pitch is lower. And it sounds like this. We've all heard it. Same thing with starlight. When yellow light moves toward you, it turns greenish and bluish. When a yellow light moves away from you, it turns reddish. Now, how can you memorize this? Well, I was reading a paper a few years ago, and I read this fascinating story of a high school physics teacher who got a speeding ticket for running a red light. The physics teacher went to the blackboard and said, Your Honor, my car was moving toward yellow light. Light is compressed in the forward direction when you move toward it, and therefore it turned green. This is the Doppler shift, he said, and he went to the blackboard and he correctly wrote down all the equations of the Doppler shift. And then this high school physics teacher said, Your Honor, I do not deserve a traffic ticket. Well, the judge scratched his head, and according to the article, the judge said, well, I guess there is a law higher than the laws of the state of New Jersey, and these are the laws of physics. But then according to the article, there was a high school kid in the courtroom, and he raised his hand, and he said, Your Honor, I'm just a high school kid, but I happen to be in his high school physics class, and he just taught me weeks ago that this only happens when you approach the speed of light. End of article. To this day, I still don't know what happened to that poor high school kid, but I tell my students that if I'm ever in court arguing a speeding ticket for a red light, they better not raise their hand if they know what's good for them and they know what's good for their grade. So, when we look in the heavens, we look at starlight emitted from distant galaxies, and we find that the light is slightly reddish, redder than it's supposed to be. That means that these objects, these gigantic galaxies, are moving away from us, and therefore the universe is expanding. Well, we can run the videotape backwards. And by running the videotape backwards, we can then calculate when all these galaxies came from a single point. And that's how we calculate the age of the universe, by simply hitting the rewind button when we calculate the expansion of the universe. So by running the videotape backwards, we see that the universe is about 13.7 billion years old, plus or minus 1%. So we now know the age of the universe, 13.7 billion years, by running the videotape backwards. But what happens if we hit fast forward? What happens if we go forward in time billions of years? Well, here it gets murkier. But by analyzing how the universe has been expanding in the past, we used to think that the universe is slowing down. We used to think the universe is aging and therefore it's slowing down, running out of steam. Wrong. We now believe that the universe is speeding up. It's actually accelerating. It's in runaway mode, which means that instead of dying in a big crunch, we'll probably die in a big freeze. We're not positive. We don't know if this will keep on for billions of years. But if so, the universe is in a runaway mode. It means that one day, perhaps when we look at the night sky, perhaps we'll see almost nothing, because the distant galaxies are so far that light cannot even reach our telescopes. Not a pleasant thought, but our universe may eventually die in a big freeze rather than a big crunch. Nobody knows when this big freeze will take place or if it will ever take place. However, estimates have been made, perhaps hundreds of billions of years, perhaps trillions of years. One day it'll get so cold that you look at the night sky and it'll be almost totally black. All the stars will have exhausted all their nuclear fuel. The universe will consist of neutron stars, dead black holes. The temperature will reach near absolute zero. And at that point, even consciousness, even thought itself cannot exist. And some people think that perhaps the laws of physics are a death warrant to all intelligent life, that we're all going to die when the universe freezes over. But you know, there's a loophole. There's a loophole in the laws of physics. You see, trillions of years from now, perhaps intelligent life will be able to master what is called the Planck energy. The Planck energy is the ultimate energy. It's the energy of the Big Bang. It's the energy at which gravity itself begins to break down. You know that if you have a microwave oven and you heat it up, you can take ordinary water and make it boil. Ice can melt, water can boil. But what happens if you crank up that microwave oven even more? Eventually the steam starts to break up into oxygen and hydrogen. If you crank it up some more, all of a sudden ions form. Atoms themselves begin to rip apart. And then if you crank up that microwave oven even more, then even the nucleus begins to break apart and you get a plasma of protons and neutrons. You crank it up some more and you get gluon plasma. And if you crank it up some more to this incredible energy, 10 to the 19 billion electron volts, we're not sure, but perhaps even space itself begins to boil. Even space-time becomes unstable. Bubbles begin to form at this Planck energy. And perhaps these bubbles are gateways to a parallel universe. Now, of course, we're not sure this is sheer speculation, but there are theories which say that there could be universes right next to